Well, hello Internet, and welcome to part 6 of my C video tutorial. Today I'm going to cover 5 things you guys have asked for many times, being structs, unions, enumerated types, linked lists, and recursive structures. If you didn't watch part 5, I spent a lot of time talking about structs there, so you might want to take a look at that, and I provide a link in the upper right hand corner. And aside from all of that, I have a link to all the code in the description for this video, and it's heavily commented and recommended for translation. So I have a lot to do, so let's get into it. Okay, I briefly want to give a little presentation here just to get our minds in the right mindset. Now, as you may remember in the last tutorial, I talked about weight and height. But you may say to yourself, but there are many ways to weigh and measure things. Like, for example, weight might be in pounds or grams or kilograms, and a measurement might be in centimeters, feet, or inches. Is there a way to store all those different types of weights and measurements, or just pure data, all in one variable? Let's say, for example, we are selling oranges. Now, we could sell oranges on an individual basis, we could sell them per pound, or we could sell them as orange juice. How can you store data of different types? Or, basically, is it even possible? Well, the answer is a union. Basically, what a union is going to allow you to do is store one piece of data that can be of a different type. It can be an int, a short, a float. Basically, declaring a union data type is like saying a variable is sometimes an int and other times a float or some other data type, but never both at once. And I want to make it very clear. You cannot store more than one value in a union variable. And I'm going to show you later on in the tutorial exactly why you can't do that. So probably the easiest way to get used to a union is to just basically create one. So we're going to use type def again so that we can give it a very specific name. Then you follow that with union. And then at the end of this, you're going to have exactly what you want your new data type to be called. I'm going to call it amount. Now I'm going to guess here that nobody's going to buy 255 oranges for $114.75 individually when they could buy a pound for $96.90. So what I'm going to do, if they are buying oranges on an individual level, I'm going to guess that that is going to be a short. However, if we are also going to allow them to enter in pounds, that's definitely going to be a float, and also ounces are definitely going to be floats as well, and I'm just going to leave that as ounce. So, okay, you have your new customized data type all set up. How exactly are you going to add values to it? Well, there's actually a couple different ways. One of them is using what is called the Designated Initializer, and it's just a big word. Basically, this is your data type. You just created it. It's called amount, and we're going to create a variable called orange amount, and we're going to give the specific ounce part of this the value of 16, and that is how you do it. Another way that you might be able to do this is to again create amount, and then you could go orange amount. Obviously you can't do this at the same time because both these variables have the same name, but you could go orange amount, and if you wanted to set a value specific to the individual or the short version of your customized data type, you could do it that way. So you can either do it this way or you can do it that way. Basically, you're going to do this a lot, and the reason why is very often you're going to also use this way of adding values in structs, which I'm going to show you in a minute, so get comfortable with this, even though it's a little bit funky looking. Now I want to again reiterate something that I think is the reason why people get confused by unions, because really they're not that complicated. What you must understand, however, is a union only holds one value at a time. It may seem as if it can hold more, but that is merely a coincidence because values are actually stored in a block of memory, and it is possible for you to use a different conversion character and make it seem like multiple values are stored in memory. And I'm going to show you exactly how that would work and why that adds to confusion. Okay, so we basically have these two guys here. We have an ounce and an individual as it would seem. What I want to do now is go printf and say orange juice amount. And then I'm going to say that I want 2 decimal places and it's a float. And I'm going to put the size in here as well. How many bytes? Put a column at the end. And then I'm going to go orange amount, which is my variable name. That's how I'm going to get the value back out, just the same way I put it in. And I'm going to say ounce. And then also I'm going to do size of orange amount ounce. Now this shouldn't work, and let me show you why. You set this value up here. Then you created this. This changes the value for orange amount. But the reason why people think it will work is because very often it does, as you see right there. See, 16 and 4 shows up. But I'm going to show you exactly why you can't rely on that here in 1 second. Right after I show you the proper way to do this, we're going to go number of oranges. Change this into a D because it's a short. This guy up here, what we're going to be working with. Size of can say exactly the same. I'm going to say individual, and I'm going to say individual. Save that, and there you can see. This actually makes it look like both of the values are stored inside of there. Nah, not really. And now I'm going to show you why that is true. Well, another weird thing that happens before I leave this, let's just change this to F. File save, bounce over here. See, 16 shows up inside of there. See, you can mess around and do all kinds of weird things here. You're playing around in memory. Now what we're going to do is we're going to go orange, amount, and pound. And this guy is also going to be a float. And if we look up here, you can see pound and ounce are both floats, while individual is a short. So what would happen if I come in here, now that my value for orange amount is a pound and also a float, and I'm just going to change this into pound and change this into pound, save it. And if we zoom in, you can see indeed that everything shows up exactly as it should. However, once again, if we go in here and change this to F for a float and execute, now you'll see 16 shows up there again. So it's testy when you are using a union and you don't want to rely on these results because they can just be wacky sometimes and not work the way that you think that they should. Now I'll show you exactly how you can use a union inside of a struct. So here we're going to go type def and create a struct. Then inside of it I'm going to go character, and let's say that we have a brand. Then I'm going to use my new amount union, and I'm going to call it the amount this time, and I'm going to call this orange product. Now we're actually going to be able to initialize this struct using the designated initializer just like we did previously. And to do that we're going to go orange product, and I'm going to call this product ordered is equal to, and here I'm going to say Chiquita, which I'm not sure if I spelled that right, but either way. Now if I want to add a value to the amount, this guy right here, what I need to do is go dot the amount dot ounce is equal to 16, and that is going to be the way that we add values to this struct using the designated initializer. And another reason why the designated initializer is kind of useful. Now if I want to print this out, I'm also going to use the dot operator. Let's say I go you bought 2F ounces of oranges, throw in that comma, and then if I want to get out my values, I just go product ordered, the amount, and then I'm going to say ounce because that is the specific type that I want to pull out of there. Then I'm going to say product ordered brand and execute, and you'll see it says you bought 16 ounces of Chiquita oranges right there. Clear that back. And that's going to bring us back to the problem that we had above, where we had potentially bad data if the wrong conversion characters were entered. There's actually an easy way to solve that problem, but first we need to learn about enumerated types. Now basically, what an enumerated type is, there's type def again, you're just going to type in enum, and you're going to use one of these guys whenever you know that you will never, ever need anything but the values that go inside of here. So we have individual, abbreviated, ounce, and pound. Those are, we're pretty positive, going to be the only types of data that are going to be stored inside of that. Now let's say we go quantity, and this is going to be homework for you guys, because you're always asking me for homework. I'm going to have quantity type be individual, and your homework is going to be to put this guy inside of the struct and make it work. I'm sure you can do it. Alright, so now let's say we go orange amount individual is equal to 4. Well, what we can do now is check what exact type of data is coming in. So if it's individual, we can do a completely different thing. For example, we could say printf you bought, and then we know that this is going to be a short, oranges, like that, and then we can get it by going orange amount individual. Else, if quantity type is going to be an ounce, don't forget to put that brace in there, well then we know that we're going to be dealing with a float. We could say something like ounces of oranges, and everything else is the same, and then call for the ounce version of this. Else, we can get rid of this altogether. We know that we're going to be dealing with a pound, so change this into F, and then say pounds of oranges, and again that final comma, and then get the pound amount. And I actually forgot with the enumeration type up here to go in and type in quantity. Sorry about that. You definitely have to give it a name, and then we use the name right there. Okay, let's save that and execute. And there you'll see that you bought 16 ounces of Chiquita oranges, and then it also says you bought 4 oranges. And if we would go in here and change this quantity type to ounce, you can see you bought 1.5 ounces of oranges shows up inside of there. So that covers unions, enumerated types, different ways to use structs, confusion that might be caused with conversion characters, and the fancy name designated initializer. So up next, I'm going to cover also a fancy name, a recursive structure, and a linked list. Okay, so for this one, I'm going to go in here and create myself another struct, and it is going to be a product. You're going to find out here in a second why I have to give this a name. And also remember, if you do want to do type definition, you have to put product here at the bottom. And let's say that we have a little store. And in our store, we want to track all the different products we have and also the price. So how exactly would I then store a bunch of these products inside of a computer program? Well, you might say, well, why don't you just go in here and go product, the products, and we have 20 products to sell, and we're going to create ourselves an array. Well, there's one really big problem with that, and that problem is an array has a fixed length. There is, however, something that does not have a fixed length, and that is known as a linked list. Basically, a linked list can store an unlimited number of items. I mean, obviously, if you have enough memory to hold all that data. And it's going to be called a linked list because it contains an item with information such as name and price, but it's also going to have a link, which is going to be a pointer to the next struct in the list. And that is what is going to create a recursive structure, which is just a linked list that has a bunch of structs inside of it. That's all it is. So what we need to do is go struct and product, and this guy is going to point to the next struct in our linked list. And that, by the way, is the reason why we have to have product here, is because we reference product here before we get down here. So there you go. If you don't do that, see, we'll get confused. Another side benefit to linked lists is you're going to be able to insert new items into pretty much any place in the list if you decide to reorder them. And it's also pretty easy to put values inside of it. So let's go and let's just start creating some products that we want to store. So we'll go tomato and let's say it's 51 cents. Then we're supposed to have the link to the next struct in the list, but it doesn't exist yet, so we can't do that. So we're just going to put null inside of there. And let's just say we have 4 items total, or 5 items total in our store. Potato, say the potato is $1.21 a pound. Lemon, $1.69 a pound. Milk, $3.09 a gallon. And then finally, let's create turkey. Oh, sure we can make this lowercase. That'll cause confusion. And turkey. And let's say that our turkey is $1.86 a pound. Okay, so we just created a bunch of structs. Now we have to turn them into linked lists. It's actually pretty easy to do. All we need to do is go tomato and next, which is this boy right here. However, we have to get a pointer to the next struct in the list. So we just go to ampersand and potato, because potato is the next item in the list. Now we're only going to have 4 of these because turkey isn't going to have one, so we're going to leave that as null for now. Then what we need to do is take potato and put potato down here. And then we have to look at the next item in the list, which is lemon. Then take lemon, put lemon down here. Of course, you could do this in a function or something. And lemon points to milk. And then finally, milk is going to point to turkey. But you may ask, or you may remember that I said you could easily insert values. You actually can pretty easily delete them as well, but I'm not going to get into that. There's homework for you as well. Let's say you have apples that you want to start selling, but you don't want apples to be after turkey. You want them to be after lemons, for example. It makes more sense. There we go. We have to create an apple struct, $1.58, null. And then basically, if we want it to show up after lemon, what we need to do is go lemon, your next is now going to be equal to apple, and apple, your next, is now going to be equal to milk. And there we go. But now what if we want to print all this information out to test that we actually did this right? No problem. I'm going to do this in a function. And as you're going to see as this tutorial continues, we're going to be using a lot more functions when we're actually writing real programs. We have to go create it, put it down here. It's not going to return anything, so put void in the front. And what's it going to be receiving? Well, I guess I should go down here and point out exactly why I put tomato in here. Tomato is the first item in the list. That's the reason why tomato is in there. I want to send it the first item and basically say after that, get me all the other items until none exist. Think about how we're going to figure out when there are no more items to print. Okay, so we're going to be getting a product pointer, put a P in front of that for pointer, and I'm going to say product. It's the name. Alright, so what do we basically need to do here? Well, we need to continue printing out names and prices while the value for next for our struct inside of our linked list is no longer equal to null. That's the answer to the question I just asked. And that's going to signal the end of the list. Otherwise, if next is not equal to null, we want to keep on going. So we're going to use a while, because I said while something is going on, I want to keep on doing it. So while loop sounds like a good thing to use. And I'm actually going to show you multiple different ways to print out these values in the struct. I'm going to use this notation with your struct name followed by whatever. And I'm also going to use the notation that looks like a little arrow. So just so you know. So we're going to go printf, and we're going to keep this simple. We're just going to say a string, which is going to be the name, costs, and then we're going to print out the price. And then I'm going to use both the notations just so you're comfortable with them. P product. And if I want name, I do that. But the easier way to do it, or at least the prettier way to do it, is to use the little arrow like that. And then, of course, after that is done, we want to change P product and make it equal to P product and get the next pointer. And if we save that and execute, you can see that everything printed out and we had no errors. So that was a lot of fun going through all those different things. If there's any confusion out there, please leave your questions in comments below, and I will definitely cover them, maybe even fit them right into the tutorial. Otherwise, till next time.